Okay, let's dive into this. Welcome to the Explainer. Today, we're going to keep things super tight, well under 5 minutes, because we are jumping straight into the absolute mechanical heart of how we actually harness light. We're talking about the mechanics of three-level lasers. Let's get right to it. To ground these abstract quantum concepts in reality, we've got to look at a true historical milestone, right? The Ruby laser. This wasn't just some theoretical idea on a whiteboard. It was literally the very first laser ever built. Notice the specific makeup we're dealing with here. We've got chromium ions, that's Cr3+, embedded right inside an aluminum oxide crystal lattice, Al2O3. It's this exact, very specific physical combination that lets scientists first observe the three-level mechanics we're about to break down. Now, what's really interesting about this atomic playing field is how it's mapped out. You've got three distinct energy levels. Down at the absolute bottom, there's E1, the ground state. Then, way up top is E3, the excited state. But here is the crucial contrast. E3 is highly unstable. It is very short-lived. Right in the middle, though, is E2, the metastable state. It hangs around just a bit longer. And honestly, that tiny extra fraction of a second, that is the secret ingredient that makes a laser actually work. Let's look at how this kicks off a chain reaction. Think of this like a high-speed atomic action sequence. Step 1 is pumping. We blast the atoms with an external energy source, like optical pumping, and that forces them to jump all the way from that E1 ground state straight up to the short-lived E3 excited state. But they can't just stay up there. So step 2 hits. They undergo a super-fast, non-radiative decay, basically dropping right down to that longer-lived E2 metastable state. And they park there, just long enough to set up the grand finale. Step 3, laser emission. The atoms finally drop from E2 back down to E1, and boom! In doing so, they emit that brilliant, highly organized beam of coherent light. So the crucial point here is something called population inversion. If you only remember one single thing from this entire explainer, let it be this. For that step 3 stimulated emission to actually give us a laser beam, we have to achieve a state where the atoms just hanging out in the E2 metastable state literally outnumber the atoms sitting down in the E1 ground state. This totally unnatural imbalance, this inversion of the normal population, that is the absolute mechanical heart of the laser. Without it, you just get some scattered light. You definitely don't get a laser beam. But, well, here's where we hit a massive roadblock. The catch is that E1 is the ground state. And as we know, the universe naturally loves the lowest energy state. Atoms are essentially inherently lazy. Practically all of them just want to chill at the bottom by default. So we're basically fighting an uphill battle against the fundamental laws of nature here. We have to force enough atoms out of bed, push them up from E1, and somehow hold them in E2 just to achieve that population inversion. And this brilliantly illustrates why this system has some major drawbacks. Because that ground state is so incredibly crowded, achieving population inversion is honestly just brutally difficult. To overpower nature's default laziness, you have to pump in absolutely massive amounts of external energy just to empty out that ground state. And because you are pouring so much raw power in just to get the whole process started, the overall efficiency of a three-level laser is noticeably lower. I mean, it requires some seriously heavy-duty hardware compared to the tech that came after it. Which leaves us with such a fascinating problem. We've just seen how the very first lasers used this three-level architecture to successfully harness light. But man, they demanded immense energy just to fight that naturally crowded ground state. So what does this all mean for the future of the tech? If this three-level system is fundamentally bottlenecked by its own mechanics, how does adding just one single extra energy level, a four-level system, completely change the game, bypass that heavily populated ground state entirely, and just absolutely revolutionize laser efficiency? Now that is the perfect question to ponder until our next explainer. Keep questioning the mechanics of the world around you.